Hello dear students, welcome to GDC classes English. So before starting with our topic today, we have a very special and important announcement to make that we are going to start our new batch for GPAT 2025-2026, especially that too in the English language, designed for you all to better understand the concepts and to it is framed in a way that you can just attend the live classes also, you can attend the pre-recorded lecture series also, you can get daily practice papers for the same, and you get a lot of test series for the same. The key features have been mentioned here. The admissions are open. Live classes are going to commence from the 15th of July 2024. For more information, you can connect to the numbers that have been mentioned in the poster below, right? And you can download our app from the Play Store and you can just enroll yourself for a better, just to see a better version of yourself. This batch is specially designed for you all in English language preferably, right? Again, the key features will be around 500 plus daily live classes. There will be 500 plus online test series available for you all, and there will be daily practice papers for your better preparation with solving of the previous year papers and pre-recorded video lectures. Okay, so you can just download the app or you can connect to the numbers that are mentioned on the screen below. Okay, then you can just save the date. We can all connect on 15th July 2024. The live classes are going to commence from the same, and you can just if you have any query, you can directly reach out to the numbers that are mentioned below. Okay, so another thing that we have started about the Margdarshan series. So here we are with another lecture to discuss about that includes the major portion that is an important topic from an exam point of view, that is the drug metabolism. So today we are going to discuss all about the drug metabolism, and in the upcoming videos you will be able to see the questions on the particular topics from the particular topics, and all the important questions that have already been asked in your exam, and the topics that you need to cover for, to buckle up with your preparation ahead for the upcoming exams. Okay, so drug metabolism, you can see in the image, this first poster that you can see is mainly includes your liver. So that is the major site for the drug metabolism. Okay, so what actually means drug metabolism? Why there is a need for drug to get metabolized? Okay, so drug metabolism is actually the chemical alteration of the parent drug that metabolizes, and the major site for the metabolism is the liver, into a metabolite. Now this metabolite not necessarily should be inactive, it can be even more active from your parent compound or less active or inactive from the parent compound. Highly depends upon the parent compound and the type of metabolism it is going to undergo. Okay, then this drug metabolism is facilitated by one important organ, that is your liver. Okay, liver is going to metabolize the drug and convert it into its metabolites. Okay, so this will be your important topic for today. Not only liver, kidneys, lungs, intestine, placenta, adrenal gland, all these also play an important role in the drug metabolism, as well as there are certain enzymes called the drug metabolizing enzymes, the microsomal enzymes, the known microsomal enzymes. You need to understand all these topics before commencing it with the questionnaire part. Okay, so now introduction to the biotransformation. First thing first, why do you need to convert your drug into a metabolite? Okay, so the parent drug is actually converted into its metabolite. Okay, this metabolite is actually it's converted so that the excretion or the elimination gets faster. Okay, so the nature of the drug, if it is lipid soluble, it is converted into a water soluble metabolite, so that the excretion turns out to be faster. Okay, this chemical alteration is termed as the biotransformation because it involves a lot of processes, a lot of enzymes are also involved in converting these parent drug molecules into their metabolites, right? It basically converts your water soluble compounds into the lipid soluble compound into the water soluble ones, so that they are better and fastly excreted in the urine. And as mentioned, the major metabolizing site is your liver. So few things to discuss before getting into our topic is the important points about the major metabolizing organ, that is the liver. We have seen that it is the major organ for the drug biotransformation or the drug metabolism. Okay, although kidney, lungs, placenta, skin also contains enzymes which can help in the biotransformation, but it is the major metabolizing organ, right? So mostly after the metabolism, as I mentioned, if it is your drug compound, it is not necessary that your drug compound will be inactive after the biotransformation. Drug compound, when converted into a metabolite, there are a lot of properties that influences their interconversion, their biotransformation. Okay, so the drug compound, if it is active, there is a possibility that the drug metabolite can become inactive after the biotransformation. There are highly chances if the drug compound is active and the metabolite becomes more active after biotransformation, or if the drug compound is inactive after biotransformation, the metabolites gets more active. This is a pro-drug approach, right? That is, the drugs after biotransformation actually turns out to be more active than the parent compound. Okay, so generally why this biotransformation happens, I have told you. The drug compound, generally they are lipophilic. There are more synonyms for it. Lipophilic are also termed as the non-polar ones or the hydrophobic ones. Okay, these are converted into the metabolites which are hydrophilic, which are polar, and lipophobic. Okay, so that they are excreted faster. This is the whole concept behind it. But sometimes the exceptions do lie. The compound, the metabolites gets more active than the parent compound. Okay. One more thing you have seen, the lipid molecules, the lipid soluble ones are actually able to pass through the cell membrane pretty much very easily and are generally reabsorbed by your renal tubular cells. That is why they tend to remain in the body. For eliminating them, they need to be biotransformed or converted into the metabolites, so they are not reabsorbed there and are eliminated really quickly. Okay. Few important examples to note which molecules get active or which molecules get inactive. There are few examples. First is your amphetamine. First one is your amphetamine. Now this amphetamine is actually an active drug which after biotransformation is converted to phenylacetone, that is your inactive metabolite. Okay, this is an important example. Second one is your codeine. Codeine is an active drug. After biotransformation, it is converted into morphine, which is yet another active metabolite form. Okay. One more is the phenobarbital. This is an active compound drug which after biotransformation is converted to hydroxyphenobarbital. That is inactive. Okay. Another important example is of sulfasalazine. Okay, this is inactive. This could be a prodrug approach. This is converted into its active metabolites. This is further converted into its active metabolites, which is the 5-amino salicylic acid plus sulfapyridine. Okay, these are the active metabolites. Another important example is of proguanil, which is inactive. That after biotransformation is converted to cycloguanil. That is the active metabolite. So you have seen the examples where even after biotransformation, it is not necessarily that the metabolites get inactive and ready for the excretion, but it can get even more active to show the better therapeutic effects, the better therapeutic properties, the exceptional properties may come which you have not even expected out of the parent compound into its metabolite form. They can turn into a more active metabolite. There can be conversion of inactive to active or active to inactive. All these depends on the nature and type of the drug molecule and the type of biotransformation reaction it is going to undergo. Right. So major concern with the metabolic pathway is the clearance. They all are metabolized so that they are excreted like really quickly. Okay. So these processes of biotransformation can produce metabolites which alter the physicochemical, physiological, pharmacological and toxicological profiles. Now this drug metabolism occurs at the specific location, resulting in a low concentration of active metabolite in the systemic circulation. Now this important point, we have discussed it multiple times, is the first pass metabolism. Again and again you need to understand about it. First pass metabolism. It is also known as pre-systemic metabolism. Okay, pre-systemic, before going into the bloodstream for absorption, metabolizing before that, the drug molecule that you have administered reaches liver where its biotransformation is going to happen. Okay, whatever amount of drug that you have taken, it is supposed that there are enzymes which tend to degrade the drug molecule, whereby around 50% of its bioavailable fraction is reduced and other 50% is now available for the other processes. Majority of the compound is degraded here. This is termed as pre-systemic metabolism. Whereas if you directly inject the drug into your systemic metabolism, if you directly inject the drug into your bloodstream, into your systemic portion, it is known to be 100% bioavailable because it actually bypasses the first pass metabolism effect. very important from your exam point of view. Okay, now this biotransformation, there are a lot of enzymes. I've told you there are enzymes that predominantly present in liver, play a major role in the biotransformation, which are referred to as CYPs, that is the cytochrome P450. In them generally there is an enzyme CYP3A4, which is the most common enzyme responsible for the biotransformation of the drugs. Okay, the major site, yes, as discussed, is the liver, where the major metabolism is going to happen. However, there are other sites to it, including the kidneys, the intestine, the lungs, and the blood plasma. The biotransformation may convert the active drug into your inactive metabolite, or the active drug into an active metabolite. Hereby you can see the examples below. The inactive drug into your active metabolite, which is yet again termed as your pro-drug approach, whereby after the metabolism of the drug, the metabolites gets even more active and even more produces better therapeutic effects than the actual parent compound. The example of the same will be levodopa, inactive form converted into dopamine after the biotransformation. Okay, so here is a summary where you can see what are the key features or things you need to see before your drug undergoes a metabolism process. So drug when enters the liver, it is going to experience one major effect, that was your pre-systemic metabolism. That is your first pass effect it is going to experience. Afterwards, there includes the biotransformation reactions, which are of two types generally, phase 1 and phase 2 reactions. Students, from your GPAT exam point of view, this is highly important. They are classified into phase 1 and phase 2 drug metabolism reactions. Now, before looking into this, I will draw another basic diagram where you can understand. Suppose this is the drug that you have administered. Alright, firstly there will be phase 1 reaction that is going to happen. Okay, this phase 1 reaction will produce inactive metabolites, okay, this is going to produce inactive metabolites. Okay, these inactive metabolites are either passed on for the excretion purpose, or they might enter into the phase 2 of the biotransformation reaction, where followed by this will be converted into another metabolite and then excreted. This is a simplified pathway where you can see how the drug is going to get metabolized. Other than these phase 1, phase 2 reactions, there are microsomal enzymes, okay, which are going to degrade your drug molecule, right? These microsomal enzymes are present in the endoplasmic reticulum. Okay, so student, this was all about your basics that we are going to cover in your drug metabolism. Afterwards this, we are going to see what are the types of phase 1, phase 2 reactions, okay, and how what are the drugs that are metabolized, tend to get metabolized by the microsomal enzymes, or if they are inducers or they are inhibitors of the microsomal enzymes. Okay, this was just a basic of what is going to come ahead. Okay, now again, before turning it off, there's the announcement yet again. Please, it's a request for you all to basically just contact the given numbers so that you can get more information about the batches. The admissions are going to start real soon from the 15th of the July, and the live classes are going to get started. Admissions are open. We'll be discussing in the English language only. The Margdarshan series are also going on, and it's a great opportunity for you all to not to miss out and gear up your preparation. So thank you so much. We'll meet in the next one.